Hello students, in this class we are going to discuss a new chapter, Parabola. Weightage of this chapter is 5 marks. It contains 2 marks 1 question and 3 marks 1 question. Here parabola is the one of the conic section. So conic section is nothing but curves. Conic section nothing but curves obtained by intersection of a right circular cone by a plane. Here observe, intersection of a right circular cone by a plane. So consider here observe, here the plane cut the right circular cone horizontally, means parallel to base. Here base is the circle, therefore called circular cone. Okay, here observe, we get a curve. This curve is called circle. Here observe, here the plane cut the right circular cone slantly. So here the curve obtained, this curve is called here ellipse. Okay, observe here the plane cut the right circular cone. Here it is parallel to this edge. Okay, here we get a curve. This curve is called parabola. Observe here this plane cut only one nap. Here this portion is called upper nap. This is called lower nap. Okay, here observe, in this case it cut only one nap. Observe here the plane cuts the right circular cone, it cut both the naps. In this case we get a curve is called hyperbola. So these are the parts of the cone. Here circle, ellipse, parabola, hyperbola are the parts of the cone or section of the cone, so called conic sections. Okay, so in this chapter we will discuss only parabola, types of parabola and their characteristics. So analytical definition of conic section is, conic section are the analytical definition. Okay, first consider a fixed point F and a fixed line L. This is the fixed line L, and then consider arbitrary point P. P means moving point. So conic sections are the locus of a point. So this is the moving point. Conic sections are the locus of a point which moves on a plane such that the ratio of its distance from the fixed point, here fixed point is F, means PF, to its distance from the fixed line. Fixed line means here L, denote this point to be M. So PM, ratio of its distance from the fixed point to its distance from the fixed line is always a constant. Is always a constant. This constant ratio is called the eccentricity. This constant ratio is called eccentricity. It is denoted by E. Okay, eccentricity is denoted by E. Suppose eccentricity is equal to 1, then the curve is called, if eccentricity is equal to 1, then the curve is called parabola. Suppose then the curve is called parabola. Suppose if eccentricity is less than 1, then the curve or conic is called ellipse. Suppose if eccentricity is greater than 1, then the conic is called hyperbola. Okay, here eccentricity is equal to 1 means this ratio is equal to 1, means PF divided by PM is equal to 1. Is equal to 1 means PF is equal to PM. So PF is equal to PM means distance of a point from the fixed line, distance of a point P from the fixed point F is equal to distance of a point P from the fixed line. So these two are equal, then the conic is called a parabola. So parabola means it is the locus of a point which moves on a plane such that its distance from the fixed point is equal to its distance from the fixed line. These two distances are equal, then the conic is called a parabola. Okay, next let us derive standard equations of parabola. So before that, just consider fixed line L, F is the fixed point, parabola, consider arbitrary point P and the parabola. Next, draw perpendicular to the fixed line from the fixed point. Okay, draw perpendicular, denote this point to be M. So clearly this is the midpoint of FM. By considering the midpoint of FM O as the origin, now introduce a coordinate system or coordinate axis. By considering midpoint of FM as the origin. Okay, here F is the fixed point. So this fixed point is called the focus of the parabola. This fixed line L is called the directrix. Fixed line is called the directrix. Fixed point is called the focus. Here the point of intersection of parabola and the axis is called the vertex. Here observe the parabola is symmetric with respect to x-axis. Therefore here x-axis is called axis of parabola. Here x-axis is called axis of parabola. Here y-axis is called tangent to the parabola. Here y-axis is called tangent to the parabola. Okay. Next let us discuss standard equations of parabola. Standard equations of parabola. So draw a diagram. Okay, consider a fixed point denoted by F. This is the fixed line L. By considering, so next draw perpendicular to the fixed line from the fixed point F. Next by considering the midpoint of FM O as the origin, introduce a coordinate system. Okay. So first let F be the focus. F is called here focus. F be the focus and L be the directrix. L is called directrix. F be the focus and L be the directrix. Next draw FM perpendicular to L. Draw FM perpendicular to L. Next, by taking midpoint of FM as the origin, introduce a coordinate system as shown in the figure. take the midpoint of FM as origin O and introduce coordinate system. Introduce the coordinate system or coordinate axis. Coordinate axis as shown in the figure. Okay. Next, let's consider arbitrary point on the parabola. I consider P. Coordinates are x, y. P be any point on the parabola. Let P of x, y be any point on the parabola. P be any point on the parabola. Okay. Next, let this distance FM is equal to 2a. Okay. Let FM is equal to 2a. Means let distance between directrix and fixed point is equal to 2a. O is the midpoint. Therefore, this distance is equal to a. This distance is equal to a. But here we measure along negative x-axis. Therefore, this distance is equal to minus a. Okay. This distance is equal to minus a. So, there implies OF. O is the midpoint. Therefore, OF is equal to OM. OF is equal to OM is equal to A. Then F is equal to. Okay. F is equal to coordinates of F. Here observe. This point lies on the x-axis. Therefore, y coordinate must be equal to 0. X coordinate means perpendicular distance from the y-axis. So, therefore, this distance is equal to a. Therefore, coordinates of F is equal to a, 0. So, next, join these 2 points and draw here perpendicular to the line L. Denote this point to be B. Okay. Next, coordinates of B. B is equal to. Okay. Here, observe. X coordinate. X coordinate means perpendicular distance from the y-axis is called x coordinate. So, this distance is equal to minus a. Therefore, x coordinate is equal to minus a. Y coordinate means perpendicular distance from the x-axis. Observe, this distance is same as this distance. This distance means perpendicular distance from the x-axis is called y coordinate. Therefore, this distance is equal to here y. Therefore, BM is equal to y. Therefore, y coordinates of the point B is y. Therefore, coordinates of B is minus a, y. Coordinates of B is minus a, y. Now, use the definition of parabola. So, according to definition of parabola, we get by definition of parabola, we have according to definition of parabola, P be any point, its distance from a fixed point is equal to distance from a fixed line. Means here PF is equal to PB. So, PF is equal to PB. Using this condition, let us derive equation of the parabola. So, PF means distance between P and F. By using distance formula, find out distance between P and F. So, consider this is x1, y1, this is x2, y2. So, distance formula is x2 minus x1 whole square. x2 minus x1 means square root of, distance formula is square root of x2 minus x1 whole square plus y2 minus y1 whole square. So, x2 means x minus x1, x1 means a whole square plus y2 minus y1 whole square. y2 means y minus y1. y1 is here 0 whole square is equal to. So, PB means distance between P and B is equal to square root of. Here also consider coordinates of B x1, y1, this is x2, y2. Okay, so x2 minus x1. So x2 means x minus x1. x1 means here minus a. So minus of minus a plus a whole square plus y2 minus y1 whole square. y2 means y minus y1. y2 minus y1. y1 means here y minus y whole square. Next, simplify. Square root of x minus a whole square plus y minus 0 is y. So y square is equal to square root of x plus a whole square, y minus y 0, 0 square is 0. Okay, next square on both sides. A square root get cancelled. Now expand x minus a whole square, that is x square plus a square minus 2ax plus y square. Here also square root get cancelled. Expand x plus a whole square, that is x square plus a square plus 2ax. Okay, here x square get cancels plus a square get cancelled. Therefore remaining terms y square is equal to, here right side we have 2ax. So take this term towards the right, it becomes plus 2ax. Therefore y square is equal to 2ax plus 2ax 4ax. So this is the equation, standard equation of the parabola. Y square is equal to 4ax. Similarly, we can derive equation of the parabola in the form of y square is equal to minus 4ax or x square is equal to 4ay or x square is equal to minus 4ay. So these are the standard equation of the parabola. Here observe, here consider parabola is symmetry with respect to positive x-axis. Then equation of the parabola is y square is equal to minus 4ax. Similarly, suppose if we consider parabola is symmetric with respect to negative x-axis, then we get equation of the parabola is y square is equal to minus 4ax. Suppose if we consider parabola is symmetric with respect to positive y-axis, then equation of the parabola is x square is equal to 4ay. Or if the parabola is symmetric with respect to negative y-axis, then equation of the parabola is x square is equal to minus 4ay. Conversely, suppose if the equation of parabola has y square term, if the equation has y square term, then parabola is symmetric with respect to x-axis, either x-axis or either positive x-axis or negative x-axis. Suppose if the equation has x square term, then the curve or parabola is symmetric with respect to y-axis, either positive y-axis or negative y-axis. Okay. So we have 4 standard equations for parabola. So next let us discuss one more concept, latus rectum. Latus rectum. So latus rectum means, so first consider fixed line L, coordinate system x dash. So consider a parabola, it is symmetric with respect to positive x-axis, is the focus. Okay, here latus rectum, it is a line segment. Latus rectum is a line segment. Here axis of parabola is x-axis. So latus rectum is a line segment perpendicular to axis of the parabola. It is perpendicular to axis of the parabola and also passing through the focus. It is perpendicular to axis of parabola passing through focus and whose end points are lie on a parabola. So, latus rectum is a line segment perpendicular to axis of the parabola and passing through the focus and whose end points are lie on a parabola. So, this is called a latus rectum. Next, let us derive length of latus rectum. Okay, here we want to find out length of AB. So, by length of AB means we want here distance between A and B. It is symmetric. Therefore, AF is equal to FB. So, first let us find out AF. So, by definition of parabola, we have, so here AB point on the parabola, draw perpendicular to the fixed line L, director is L, denote this point to be C. According to definition of parabola, its distance from the fixed point is equal to distance from the fixed line. So, AF is equal to AC. AF is equal to AC, but observe here AC, this point is M, here AC is parallel to FM. We know that distance between F and M is equal to 2A. Therefore, AC is equal to 2A. AC is equal to 2A. Therefore, AF is equal to AC is equal to 2A. Okay, here AC is equal to 2A. Therefore, AF is also equal to 2A. So, we know that the parabola is symmetric with respect to x-axis. Parabola is symmetric with respect to x-axis. Therefore, symmetric with respect to x-axis. So, therefore, AF is equal to FB. Therefore, AF is equal to FB. Therefore, AF is equal to A. Therefore, FB is also equal to 2A. Okay, next. Therefore, length of latus rectum. Length of latus rectum is equal to AB. Therefore, AB can be written as AF plus FB. AF plus FB. AF is equal to 2A plus FB. FB is also equal to 2A. Therefore, 2A plus 2A is equal to 4A. Therefore, length of latus rectum is equal to 4A. Okay. So, next let us discuss standard equation of parabola and their graphs and their characteristics. We have 4 types of parabola. Have 4 types of parabola. Suppose if the parabola is symmetric with respect to positive x-axis, here observe it is open towards right side, therefore it is called right-handed parabola. Right-handed parabola. Suppose if the curve symmetric with respect to negative x-axis open towards left, therefore this is called left-handed parabola. Left-handed parabola. Next, third one. Suppose if the parabola is symmetric with respect to positive y-axis. Positive y-axis. So open towards upwards. Therefore this is called upward parabola. Okay, this is called upward parabola. Upward parabola. Similarly, suppose if it is symmetry with respect to negative y-axis, then it is called downward parabola. So first let us discuss right-handed parabola and left-handed parabola and their characteristics. So first consider right-handed parabola. First one, right-handed parabola. So graph of the right-handed parabola is this fixed line L called directrix, coordinate system, it is symmetric with respect to positive x-axis, focus, this is the directrix. Here directrix are denoted by L, L dash. Endpoints are denoted by L, L dash. So this is the F, M. Okay. Here origin, therefore coordinates are 0, 0 denoted by V. So because it is called vertex, therefore denoted by V. Here F is called the focus, L is called the directrix. Okay. Here we know that distance between FM is equal to A, therefore VF is equal to A and Vm is equal to minus A. Here equation of the directrix. Here observe this directrix is parallel to y-axis, therefore equation is equal to x is equal to constant distance from the y-axis. This constant distance is equal to minus A. Therefore equation of the directrix is x is equal to minus A. Equation of the y-axis. Equation of the y-axis is x is equal to, here distance is 0, x is equal to 0. Equation of the x-axis is parallel to x-axis, therefore y is equal to 0. Okay. Equation of y-axis is x is equal to 0. Equation of x-axis is called y is equal to 0. Here coordinates of A is A comma 0. Okay. Here coordinates of M, point lies on x dash, therefore coordinates are y coordinate must be equal to 0, x coordinate is minus A comma 0. Okay. Characteristics. This is the graph of the right-handed parabola. So characteristics. First one, vertex denoted by V. Coordinates of vertex is origin, therefore 0, 0. Coordinates of vertex is 0, 0. Second one, focus. Focus is denoted by F. Coordinates are A, 0. A, 0. Next, third one, equation of directrix. Equation of directrix L is, equation of directrix is x is equal to minus C. X is equal to minus C. Next, fourth one, equation of axis. Equation of x, here x of the parabola, it is symmetric with respect to positive x-axis, therefore here x-axis is called axis of the parabola. So equation of x-axis is y is equal to 0. Axis is y is equal to 0, that is x-axis. Fifth one, equation of tangent. equation of tangent at the vertex. Here tangent at the vertex is y-axis, therefore equation of y-axis is x is equal to 0. Therefore equation of the tangent is x is equal to 0. X is equal to 0. Next characteristic is equation of latus rectum. Equation of latus rectum. So here it is also a line segment parallel to y-axis. Therefore equation is equal to x is equal to this distance, constant distance from the y-axis is a. Therefore x is equal to a. Observe here, equation of latus rectum is x is equal to a. Equation of directrix is x is equal to minus a. So equation of latus rectum is x is equal to a. Next, length of latus rectum. Length of latus rectum. Length of latus rectum is equal to, already we derived, it is equal to 4a. Length of latus rectum is equal to 4a. So next characteristic, 8th one is coordinates. Okay. Coordinates of the latus rectum. Coordinates of latus rectum is L and L dash. So coordinates means x coordinate. X coordinate means perpendicular distance from the y-axis. So this distance is equal to a. Therefore x coordinate is equal to a. Y coordinate means perpendicular distance from the x-axis. This distance, we know that length of latus rectum is equal to 4a. Therefore this distance is equal to 2a. This is also equal to 2a, but we measure along negative y-axis. Therefore the distance is equal to minus 2a. Therefore y coordinate means its distance from the x-axis, that is 2a. Therefore coordinates of end points of latus rectum, one is a comma 2a, another one L dash. Here also x coordinate means perpendicular distance from the y-axis. This distance is equal to a. Y coordinate means perpendicular distance from the x-axis, that is equal to minus 2a. Therefore coordinates of end points of latus rectum are L is equal to a comma 2a, L dash is equal to a comma minus 2a. Next, fifth one, sorry, last characteristics, 9th one, it is symmetric. Symmetric with respect to x-axis. Right-handed parabola is symmetric with respect to x-axis or positive x-axis. So these are the characteristics of the right-handed parabola. Similarly, let us discuss characteristics of left-handed parabola. So same characteristics. Left-handed parabola. Left-handed parabola means symmetric with respect to negative x-axis. Consider your focus. Consider directrix L. So this is the point M. This distance is equal to a. Therefore this is equal to a. This distance is also equal to a. This is plus a. FM is equal to minus a. This is vertex. Therefore denoted by V. Okay. So length. Directrix L dash. Okay. Yeah. Here vertex. Here also vertex is the origin. Therefore coordinates are 0, 0. Focus. Coordinates of the focus. Here point lies on negative x-axis. Therefore x coordinate is equal to minus a. Y coordinate is 0. So minus a, 0. Equation of the directrix L. Here also parallel to y-axis, therefore x is equal to Here distance from the y-axis is plus a, constant distance is plus a. Therefore, equation of the directrix is x is equal to a. Equation of the axis. Here it is symmetric with respect to negative x-axis. Therefore, here also axis of the parabola is x-axis. Therefore, equation is y is equal to 0. Equation of the tangent. Here also tangent is y-axis. Therefore, equation is equal to x is equal to 0. Equation of the tangent is x is equal to 0. Next, characteristics equation of latus rectum. Parallel to y-axis. Therefore, x is equal to constant distance. Constant distance from the y-axis is minus a. Therefore, equation of latus rectum is x is equal to minus a. Next, length of latus rectum is always 4a. Next, end points of latus rectum. Coordinates of end points of latus rectum. Here, okay. X coordinate. X coordinate means perpendicular distance from the y-axis. This distance is equal to minus a. Therefore, x coordinate is minus a. Y coordinate means perpendicular distance from the x-axis. So, length of latus rectum is equal to 4a. Therefore, this distance is equal to 2a. FL is equal to a. FL dash is also equal to 2a. But here we measure along negative y-axis. Therefore, this distance is equal to minus 2a. Therefore, here y coordinate is equal to plus 2a. Similarly, x coordinate of L dash is perpendicular distance from y-axis is minus a. Y coordinate is perpendicular distance from x-axis, that is minus 2a. Therefore, coordinates of end points of latus rectum are minus a comma 2a. L means minus a comma 2a and L dash is minus a comma minus 2a. And last one, so left-handed parabola. It is also a symmetric with respect to x-axis. Symmetric with respect to x-axis. So these are the characteristics of the left-handed parabola. Thank you.